Our star, the bringer of life, also holds the power to send our technological civilization back to the 19th century in a matter of hours. We orbit a star, our sun. It's the source of our energy, the anchor of our world, the giver of life. Its light and warmth travel 93 million miles through the vacuum of space to nurture our planet, driving our climate, powering photosynthesis, and making our existence possible. It feels so constant, so reliable, so benevolent, a steady, unwavering presence in our lives. But this perception of a calm, peaceful star is a dangerous illusion, born from the cosmic luck of living in a relatively quiet period of its long and often violent life. We have built a new global ecosystem, a civilization built on a delicate scaffolding of technology. Our power grids, our satellites, our communication networks, our GPS systems, all of it is vulnerable. We have, in effect, wrapped our planet in a sensitive electronic nervous system, and that system is directly in the line of fire of our star's awesome and unpredictable fury. On the morning of September 1st, a British astronomer named Richard Carrington was in his private observatory, sketching sunspots. Suddenly, he witnessed something no one had ever seen before: a white light flare, an intensely brilliant flash of light erupting from the group of sunspots he was observing. He had just become the first human to witness a major solar flare, an event that would soon bear his name. The flare was accompanied by something even more dangerous: a coronal mass ejection, or CME. This is a massive bubble of magnetized plasma, billions of tons of the sun's own atmosphere, hurled out into space at millions of miles per hour. This particular CME was aimed directly at Earth. It took just 17.6 hours to cross the 93 million mile gap, a journey that normally takes 3 to 4 days. It was one of the most powerful and fastest moving solar storms ever recorded. When it hit, the consequences were immediate and dramatic. Earth's magnetic field, our planetary shield, was overwhelmed. The CME slammed into it, compressing it and inducing massive electrical currents in the ground below. The nascent global telegraph system, the technological marvel of its day, went haywire. Sparks flew from telegraph machines. Operators received electric shocks, and papers were set on fire by the surges. Some systems were so supercharged by the storm that operators could disconnect the batteries and continue sending messages using only the auroral currents induced by the storm. The aurora borealis and aurora australis, normally confined to the polar regions, were seen all over the world. People in Cuba, Hawaii, and Rome saw the night sky light up in brilliant shades of red, green, and purple. The light was so bright that people in the Rocky Mountains woke up and started preparing breakfast, thinking it was dawn. It was a beautiful spectacle, but it was the sign of a planetary-scale electromagnetic disturbance. If the Carrington event happened today, it wouldn't just disrupt a few telegraph lines. It would be a catastrophe on a global scale. Imagine the Carrington event in the 21st century. The initial blast of X-rays from the flare would saturate satellites, potentially causing permanent damage and knocking out communications and GPS. Then, hours later, the coronal mass ejection would arrive. Its impact on our magnetosphere would induce powerful geomagnetically induced currents in our power grids. Transformers, the backbone of our electrical distribution system, would overheat and melt. Not just a few, but potentially hundreds of them across entire continents, plunging vast regions into a blackout that could last not for days or weeks, but for months, or even years. Without electricity, our modern world grinds to a halt. No clean water being pumped to our homes, no refrigeration for food or medicine, no functioning hospitals, no financial systems as ATMs and credit card networks go dark, no fuel being pumped at gas stations, no internet, no television, no radio, no phones. It would be a cascading failure of all the interconnected systems that support our society. A 2013 report from Lloyd's of London estimated that the cost of such an event to the United States economy alone could be as high as $2.6 trillion, with a recovery time of 4 to 10 years. You might think this is a remote possibility, a once-in-a-millennium event, but you would be wrong. On July 23, 2012, a solar storm of Carrington-class intensity erupted from the sun. An immense CME tore through Earth's orbit. But we got lucky. By sheer cosmic chance, the Earth had been in that exact spot just 1 week earlier. We missed a direct hit by about 9 days of orbital travel. We dodged a bullet of celestial proportions. A 2014 study calculated that the probability of a Carrington-level storm hitting Earth in the next decade is about 12%. This is not a question of if, but when.